Right, the data plane of VXLAN, we are going to understand how the data plane of VXLAN will behave when a known traffic comes or when a broadcast traffic comes. When a destination address is known, and if the destination is local, it won't use VXLAN. Makes sense, right? Why it should use VXLAN? When the source and the destination MAC addresses are on the same switch. Understand, this is layer 2 communication. Both source and destination MAC address are in same switch, so there is no need for VXLAN. And also it is same VLAN. There is no need for routing because it's same VLAN. So traffic will be locally forwarded. There is no need for VXLAN encapsulation. But when the destination MAC address is not local, for the destination you have an entry in the VXLAN forwarding table, which is pointing towards the tunnel interface of the local BTP, which means the destination is not on the same switch, it's on the remote switch. I repeat, this locally you should not get confused. The destination MAC address is not locally learned, but it has an entry to the local VTP tunnel, means it is showing a tunnel interface, which is a VTP tunnel. VXLAN tunnel is what we call it as VTP tunnel. Which means what? The destination is behind some other switch, a remote switch. So it will start encapsulating with the VXLAN header. With the appropriate VXLAN header means what? It will put the right IP address to where the packet has to be forwarded after encapsulation. Sorry. The forwarded traffic, forwards the traffic to the remote VTAP. And the remote VTAP only what it will do? De-encapsulate the packet. It will remove all the VXLAN related fields, headers, and forward only the inner frame to the destination port. So this is about unicast traffic. Two scenarios we are seeing here. One, the destination is on the same switch, for which there is no need for VXLAN encapsulation. Second one, the destination is on the remote switch, so my local switch will have a entry pointing towards the VTP tunnel. So immediately the switch will start encapsulating all the tunnel information so that the packet can be carried through the tunnel to the tunnel remote end. Once it goes to the remote VTP end, the decapsulation of VXLAN will happen. And just the inner frame, what is the inner frame means? We saw in the picture here. Just the inner frame, this is what that inner frame is. This inner frame is what? Delivered. This got added here because it was pointing towards tunnel, and it got removed when it is received here. Tunnel beginning, tunnel end. This got removed. Here it is added. All right. So this is for the unicast. Now, If it is a broadcast or unknown unicast or multicast traffic, what will happen? Within VXLAN EVPN data plane, the broadcast or multicast or unknown unicast traffic can be forwarded using the forwarding options like IPPIM underlay network, any source multicasting, or bidirectional PIM. Yeah, these are the methods. So if your environment is multicast environment, meaning between this and this, if you are running multicasting, with any one of this option, any source multicasting is one option, or bidirectional PIM is another option. If any one of this multicast is available, then the bump traffic, the broadcast, will not be sent as a broadcast. It will be sent only to the group members of the multicast group address. Or if traffic itself is a multicast, again it is going to use this multicast in the fabric. If the traffic that is coming from the host is an unknown unicast, then also it will be sent to that multicast group members. Because it's unknown, no? It has to discover. Those who know multicasting will understand this. What about Arul? Do you understand what I say? Let me repeat. When the when the end device generates a broadcast traffic, how that broadcast traffic will be treated in VXLAN. VXLAN will send it to the multicast group members by using any one of this multicast that we have enabled. We may have any source multicasting, or we may have bidirectional PIM multicasting. Whatever you have, it will use. So using the multicast, the broadcast traffic will be multicasted. Broadcast will not be broadcasted to all the leaf and spine. It will not be broadcasted. It will be only sent to the group members using multicast. Or if the sender, the user itself is sending a multicast, then also it is going to use the multicast method of distribution inside VXLAN. Or if the sender is sending a traffic which is unknown, what is unknown? The destination MAC address that the sender is sending is not known to the VXLAN. Even then, it is going to use that same multicast, send it to the multicast group members so that it can discover the unknown destination. If you are aware of multicasting, you will understand what this means. So my question is, do you understand really what I said? Okay, don't worry about this. Later, when you learn multicasting, if you come back after learning, you will understand this. Actually, multicasting is nothing but forming a group, finding the right group members of a multicast only to that group members. Correct. Fine. Next is the increase replication feature. This is available only in Nexus 9000 series. Increase replication. So when we were doing lab earlier, we used to try this in XR, XE, but we did not see the enough support. It is all because it's not supported there. Ingress replication is supported only in Nexus. I mean Nexus 9000, not on 7000 or 5000. You need Nexus 9000 for ingress replication. What is ingress replication? Either you statically give some destination address to which the bump traffic to be forwarded, or those destinations are learned dynamically through MPBGP control plane. So whenever there is a bump traffic, it will send only through those destinations as a unicast traffic. See, a bump traffic is coming, it is sent as a unicast packet to all those destinations which you might have configured statically, or you might have the VTEPs might have learned through MPBGP. This is what we call as the ingress replication feature. You need to understand this very well, because while configuring, we will do ingress replication as one of the method. What does ingress replication means? It means that instead of using a multicast, any source, multicasting or bidirectional PIM, instead of using this, we use specific addresses either learned dynamically through MPBGP, EVPN, or configured by the user statically. Bump traffics are sent to those destinations that are learned through MPBGP, EVPN, or configured statically. How the packets are sent? As a unicast to every individual destination, which is identified either through MPBGP or through static. Packet will be sent. So if I have 5 leaves, 5 packets of bump traffic will be forwarded. But bump traffic will not be sent as bump traffic, it will be sent as unicast traffic. This picture is an easy picture. VXLAN EVPN data plane, how it works. When there is a bump traffic, it either uses IP PIM, any source multicasting or bidirectional PIM method, or ingress replication, which we just learned. If it is known traffic, it will simply forward the traffic towards that destination, because it knows to which leaf I need to forward. Only when the destination is unknown, that is unknown, or only if the destination is multicast or bump broadcast, any of this is needed. For unicast, this is needed or what? No, not needed. So while configuring, when we say ingress replication, or when we give a particular IP address, or when we enable any multicast bidirectional PIM, which we are not doing for non-unicast, we are doing only for the bump traffics. That clarity we should have while configuring. Yeah. So any questions so far? Mhm. ಇದು industry standard da. VXLAN industry standard da. Now, as I said, in data center device, we have main access devices, but this increased replication feature is supported only in 9000. You can use other features with multicasting and all on other 7000, 5000. But if you want increased replication, the leaves need to have 9000. The leaves. Spine doesn't matter. Leaf need to be Cisco 9000. Now, yes, encapsulation and decapsulation happens only on leaf. So that leaf device need to be VXLAN supporting device. Spine doesn't matter. It needs to be a simple routing device. That's all. So now the packet structure, if you see here, this is the original frame. Original layer 1, layer 2 information will be there. And then what happens when the destination MAC address is pointing towards a remote leaf, immediately this header will get added, VXLAN header, in which you will have the VNI number. That VXLAN network identification number is there, no? Like 5001 VNI number and some reserved bits. And then UDP header, which is to tell that the next header is VXLAN. And then the IP address to which leaf the packet need to be forwarded, and the MAC address to which next hop the packet need to be forwarded. These are all the overhead. These are the additional fields that gets added if the destination is pointing towards a tunnel, VXLAN tunnel. So extra baggage of 54 bytes, 50 to 54 bytes get added. You see, in VXLAN header, you have that VNI number and some reserved fields and flags. And then on the UDP header, means layer 4 header, you have the source port number, destination port number, which is nothing but the VXLAN port number, length checksum. This is the new standard port number 4789. And then the outer IP header, based on which the packet will be routed. The inner packet will never get disturbed. The source and destination MAC address will never get disturbed. Only based on this and this MAC address, the packet will be moving. This is the upper header based on which the packet moves from one VTAP to a remote VTAP. This portion will be removed on the remote tunnel endpoint. This gets removed. Outer MAC header will be, the source address will be the sending leaf, and the destination MAC address will be the spine, so that the packet will go from leaf to spine. And then from spine, when it goes again the source address will be spine to source and destination leaf. So destination MAC address. Let me show you here. You see here. This will answer your question. The source MAC address is MAC1, which is the tunnel beginning. The tunnel. This is where the tunnel starts. And the destination MAC address is the immediate hop routing device. The source IP is this VTAP tunnel beginning. Tunnel destination IP address is what the destination IP. This will keep changing in the path for every hop. This will never change. After reaching the final VTAP, this gets removed and delivered. See, when you receive the packet on the destination VTAP, see the source. The source MAC address is MAC3. The destination MAC address is MAC4. Because this gets changed, I told you, in the path. That is, for every hop, it will keep changing. Grish? All right. So this is the header of VXLAN, don't forget. You can go through this later. I have already spoken on this and also on this. Now, if it is layer 3 packet, what it is, what do I mean by layer 3? Routing. Meaning the traffic is coming from one IP address, but going to different IP, a different subnet. For example, here the packet is 10.0.0.1. Here it is 192.168. Different subnet. Then what happens? Actually, for each subnet, there will be a privacy gateway, floating gateway. So when the traffic goes to the gateway, gateway will decide that you need to go to IPv4, IP4, which means this one. The routing device will decide. Accordingly, the encapsulation happens. As usual, routing is based on the outer header, and packet goes here. And then the top layer is removed, and then the original frame is delivered. So layer 3 also you can do over VXLAN. So VXLAN is not only for layer 2, not only within the same VLAN members, even between different VLAN members. So that is what you are seeing here. You see, this VTAP has got MAC and IP info, MAC A, IPA, belong to VNI 10. But MAC B and IPB belong to different VNI because I told you they belong to different subnet, like 192. So when A wants to go to B, it looks into this forwarding table. It says your exit is on this particular remote VTAP, and this is the VNI. So according to this info, this header will be created. This destination is determined based on this. So this will be, the packet goes here. And now when the packet comes here with the destination MAC address of IPB, it says IPB, then you have to go out on VNI 11. Actually, it was entering on VNI 10, but here it is living on VNI 11 locally on this port. Mhm. Mm. தப்பா புரிஞ்சிட்டு இருக்கீங்க. Listen here question. Instead of this one, if I have the word local, the source and destination are in same local. Then there is no need to take tunnel. Yeah, if the destination is pointed towards IP, which means that's the IP of who? The remote VTAP. Instead of saying local as a destination, if the destination is seen as a remote VTAP address as a next stop, then it has to go through the tunnel. It has to go through the encapsulation process. Header will have both layer 2 and layer 3 info. Whether you are doing IP routing over VXLAN or layer 2 communication, the outer header should have the destination VTAP's IP address, no? Because the VXLAN fabric is routing fabric, layer 3 fabric. ECMP, you get equal cost multipassing advantage and all. So header doesn't, it won't change. Even outside data center, if you want to do OTV can be used or VXLAN can be used. That is what we are trying to understand. I want to have VLAN to be extended. For example, VLAN 10, I want also to be extended same VLAN 10 both in UK and in Australia. I want to extend it. I can use VXLAN or I can use OTV. VXLAN is best because you can have multiple sites. Hmm. Listen, please. This is a nice question. It is the order in which any device will process. When a packet is received by the router, first it will read the layer 2. Is this MAC address mine? Yes, it's mine. Then I'm going to see the next header in the IP packet. What destination IP he wants to go. Okay, IP4. I know where is IP4. I will forward you, don't worry. So what it does, it changes this MAC address to source and this MAC address to destination and forwards the packet to router 2. Router 2 on receiving this packet will check whether the destination MAC address is matching with its own. Yes. If it matches, then it checks what destination IP it needs to go. Oh, you want to go to IP4. I know where is IP4. You need to go this direction. So what it does is it puts its own MAC address as the source and this IP4's MAC address, which is MAC4, as a destination and forwards the packet here. Question. Yeah, normal routing. This is not VXLAN, any specific VXLAN related. This is what we call it as routing, where MAC address determines the next hop. Okay, next. So based on the IP address, the direction is determined, and using the direction, the next hop's MAC address is derived and utilized to go to the next hop. All right, all these things are explained here. You need to go through this. Fine. Next, we already learned about bump traffic and all the stuff. Now let us focus on the unicast packet, which you already learned, but this has got a new picture here. That's all. You see this picture. I know it is very tiny. I'll try to zoom more. Yeah, this much I can zoom. Now, this is the information that you have in the routing table of this leaf, ARP table and MAC table. See, in the leaf you have, in the ARP table, that 192.168.1.10, which is connected to Ethernet 1, this interface, with this MAC address. This is local. And also it is same MAC address and the interface belong to VLAN 10. So this is VLAN 10, correct. And this MAC address and this IP address is local, isn't it? For this leaf, it is local. Now, this information will be distributed to the remote VTAP. See, same MAC address, same IP address, and this is the VNI number. This is the VTAP's IP address. This guy, if it is 10.0.0.1, an IP address. All this routers MAC, all these informations are distributed, replicated using a multicasting method or using EVPN. All right. So now VTAP2 knows that 101 of VLAN 10, correct? No, VLAN 10. He is from leaf 1. See, this is what I mean, pointing towards the tunnel. Whereas 1002 is local. Even in the routing table, if you see 10.0, 192.168.1.11 is local, whereas this MAC address is on this leaf. So the encapsulation happens with this address and this address as the on the header, and then it is transferred to this place, and then decapsulation will happen and the packet will be delivered. So this picture explains what all informations are distributed from one VTAP to another VTAP when a new MAC address is learned. When a new MAC address is learned like this locally, immediately this EVPN, network layer reachability information, NLRI, network layer reachability information, leaf 1 will send the network layer reachability information in EVPN route type 2 to advertise a new learned MAC address. This is newly learned. Likewise, VTAP2 will also advertise similar thing to VTAP1. Only then the communication between this host A and host B is possible. Is there any question? Okay, you can go through these things. I have already given the explanation to you. This is close look to the header. I hope you understand this, but still, I'll quickly explain this. This is the original Ethernet frame with the source MAC address and destination MAC address, .1Q, blah, blah. Now this is the VXLAN encapsulation. VXLAN ID will be there, UDP port number 4786, outer headers, source IP address and destination IP address. And then .1Q, if there is any VLAN tagging need to be marked like VLAN 10, 20, source and destination MAC address. The explanation is given here. Close look to the VXLAN header. This is what you need to focus. You got 24 bit of VNI, means VXLAN network, VXLAN ID. Like VLAN ID, you have VXLAN ID. VLAN is only 12 bit, but VXLAN is 24 bit. So you can get approximately 16 million layer 2 segments. Right? Okay. So that is the next. Now let us go to the bound traffic. I think I have already explained the bound traffic. You can either use multicasting or increased replication method. Increased replication is using EVPN, unicast. Or you can also statically tell to what all address the packet need to be unicasted if the packet is a bump. I think I have explained already. It's same thing with nice pictures. You can go through this. You will definitely understand. If not, I'll explain you again. Same thing what I explained on the top is being given with nice pictures. Anycast. If you are not aware of multicasting, then this will be more easy for you to understand. These are multicast related. And then pervasive gateway, floating gateway, explained. All right. So go through this one more time. We will have a quick revision and also the lab to test this.